Let's talk about the next question here. So the next question reads, using the arc length formula, find the length of the curve y equals 2x minus 5 from interval -1 to 3. And then let's check our answer by comparing its length to the distance formula. So the arc length formula uses integrals to calculate the length of a curve, and this is the formula for it. Okay, so L, I should use a different color. The formula is L equals the definite integral from intervals a to b of the square root of 1 plus dy over dx squared and dx, where function y is defined on interval AB. Alright, so that's the arc length of a curve using the integral. So in this question here, they gave us a function 2x minus 5, and they give us interval, and they asked us to find the arc length. Okay, so let's do that now. First, we want to find what y prime is, or dy over dx. So dy over dx is going to be 2. Okay, and we're going to sub that into our equation here. Okay, so the arc length equals from 3 to -1 of 1 plus 2 squared d of x. Okay, so what do we got here? We got 3 minus 1 of root 5 of dx. And from here, we understand that the integral is going to be root 5 times x from 3 to -1. Okay. And the solution from here is that we get the arc length is going to be 4 times root 5. So that's the arc length. Okay, we calculated it from using the arc length formula. And they asked us to compare the arc length, the calculated value from arc length formula to the distance formula. Right? So the distance formula of a curve is given by L equals, so this distance formula only works when we have a straight line, right? And here we do have a straight line, so we can use it. So the length, this is the distance formula, is x2 minus x1 squared. Hold up, that's not right. y2 minus y1 squared plus x2 minus x1 squared. Okay, so that's our distance formula here of a straight line. Okay, so this is the distance formula of a straight line, and this is our arc length formula. Okay, so our distance formula, so we're going to use our distance formula here. So L equals the root of y2 minus y1 squared plus x2 minus x1 squared. Okay, so we have to calculate what y2 and y1 are first. So we have x2 and x1. So x1 is -1 and x2 is 3. So here we're going to calculate y of -1, which is equal to -2 minus 5, which is -7. And we have y of 3 here, which is going to be 6 minus 1, so that equals to 5. Okay, so let's calculate our length now. All right. 6 minus 5. Sorry, this should be 6 minus 5. No, 6 minus 1. Okay, so our length is going to be -7 minus 1 squared plus 3 minus 1, which is plus 1 squared. Okay, so if we were to calculate this, we would get 64 plus 16 416. Yeah. Okay, and if we were to add this together, we would get 80. So root 80. All right, 16 times. So root of 80, we can take out 4. 16 doesn't fit in 80. Does it 16 fit in 80? Yeah, 16 does fit in 80. So it's 16 can be taken out. So this can be written as 16 times 5. And we know that this can be written as 16 times root 5. And that equals to 4 times root 5. Okay, so we see here that the length of a straight line corresponds to the length of an arc from the arc length formula. Since these are both correct, then we know that our answer from the arc length formula is correct. Okay, so this solution is correct. Good work. All right, moving on.